In previous videos, we saw a really easy way to create Catmull-Rom curves. We just use begin shape and end shape and call vertex a whole bunch of times. In this video, we'll look under the hood at how processing draws Catmull-Rom curves. This will give you some additional control over your curves for the times when the begin shape end shape version doesn't give you exactly the results you want. Let's recap the basic way that we drew a curve using begin shape and end shape. Suppose we want to draw this heart. Well, we'll draw the left side as one curve and the right side as another. So on the left side, we might create a bunch of control points and then draw a curve through them using begin shape and end shape. We would then do the same thing on the right-hand side, create a bunch of control points, draw a curve through them, and we've created our heart out of two curves. This works perfectly well, but it's something of a shortcut. Let me show you how you would do it yourself if the shortcut wasn't available for the times when you want that extra bit of control. Here's our original heart again. When processing drew the curves I just showed you, it wasn't really drawing two big curves. It was really drawing 6 smaller curves. Each of the two curves we drew on the left and the right is really made up out of 3 smaller segments. And that's the key to Catmull-Rom curves. They're built up out of small segments. Where do these segments come from? Well, of course they come from your control points. Here's our original heart, and I'm showing the control points that define the blue curve that I drew on the left. Now I'm going to go over this at a very general, broad level very quickly, so just try to get the general idea, and then we'll look at this in more detail in just a moment. To build the big curve, processing takes a series of small steps. First, it grabs the first 4 control points, and it draws a little curve between the middle 2. Then it forgets about those, and it grabs another set of 4 by skipping the first one. So it grabs control points 2, 3, 4, and 5. And it draws a curve between the middle 2. Then it forgets about those, and now it's going to grab the next set of 4 by skipping the first one and skipping the second one. So now we get control points 3, 4, 5, and 6. It draws a curve between the middle 2, and that generates the curve on the left-hand side. Now we know that that's not really one big curve, that's really 3 smaller curves. And when we draw the curve on the right-hand side, it's the same way. So this is just to give you the gist of the idea. Let me show you how you would actually do this. The basic idea is this. Anytime you want to draw a curved segment, you have 4 points that are involved. I'm drawing with open circles the first and last points, and I'm drawing as closed circle the middle 2. If we think of a curve that goes through all 4 of these, processing draws the part between the middle 2. This is the heart and soul of the Catmull-Rom curve. The stuff we saw in the previous videos is a shortcut way for creating lots of these so that they line up smoothly. But you can draw these little curve segments yourself one at a time. How do you do it? You call curve. Curve takes 8 arguments, but they're perfectly reasonable. Let's see where they come from. The first control point has 2 coordinates, x and y, and I'll call them ax and ay just to give them a label. The second point is at bx, by, the third point at cx, cy, and the fourth point at dx, dy. To draw that little curved segment between the 2 blue points, we call curve with the coordinates of point A, followed by the point B, followed by point C, followed by point D. These 8 numbers, when you hand them to curve, cause processing to draw that little bit between the middle 2 curves. So this is great. Now we know how to draw one curve segment. But of course we want our curves to be smooth. So how do I make one curve segment smoothly line up with the next one? The secret is overlapping. There is an overlapping rule that comes to us from the mathematics, which I'm not going to go into, but I'll show you the rule. Suppose I want to draw this curve, nice and smooth, but it's actually made up out of these 4 pieces. So how do I construct these 4 pieces so that they all line up so smoothly and look like just one big curve? As I said, the answer is to overlap. Let's see what I mean. So here are our control points. I'm using open circles for the first and the last one. And here's the curve that goes between them all, as if processing really did go from the very first one to the very last one. I'll number the control points, and If I handed this to processing using begin shape and end shape, we know it would draw this part of the curve between vertices 1 and 5. But we're going to draw this ourselves. First, we're going to draw the piece between 1 and 2, then 2 and 3, then 3 and 4, then 4 and 5. So we're going to build this up manually. Here's how we do it to make it smooth all the way through. I'm going to make a little chart here. These are just the vertices that are involved in drawing any segment. The first segment I'm going to draw is based on the first 4 vertices, 0, 1, 2, and 3. So there they are, and in the chart, I'm going to draw a little heavy bar between vertices 1 and 2, because that's the part that gets drawn. If we hand curve the 8 numbers for the xy of points 0, 1, 2, and 3, it will draw that segment. The shape of the curve is, of course, influenced by points 0 and 3, even though they don't participate in the drawing. Now, to make everything smooth, the next curve I draw, take a look again at the chart, is going to be between 1, 2, 3, and 4. Now, the middle 2 vertices in the chart are 2 and 3. So I'll put a little bar there, and now looking back up at the curve, when we draw the curve segment between 2 and 3, it will line up with the previous one because of all the overlapping. Well, let's keep pushing this on. The next segment will join up points 2, 3, 4, and 5. The middle 2 are 3 and 4. So looking at the curve, we're going to draw the segment between 3 and 4. Finally, looking back at the chart, we can see the last segment will begin at 3. It'll be vertices 3, 4, 5, and 6. The middle 2 are 4 and 5. Looking back up at the curve, if we draw that curve, it smoothly lines up with what came before. That's the secret. Each segment that you draw has only one new point. The first 3 points overlap with the last 3 points of the previous segment. As long as your calls to curve overlap in this way, everything will come out smoothly. Now, how about if you want to draw a closed curve? It's really the very same thing. So I'd like to draw this kind of a whale-shaped closed curve. I'm going to draw it out of a bunch of short curves, bunch of short segments, each of which joins just the middle 2 points of a set of 4. So let's see how to do this. Here are my control points, and here's the curve that I want to draw that will join them all up. Let's give them some numbers and we'll make our chart. The first segment that I draw will join together 0, 1, 2, and 3. Looking at the chart, we can see that the middle 2 vertices are 1 and 2, so I'll put a heavy bar there. And now looking up at the drawing, we know that the curve that will get drawn, if we hand curve vertices 0, 1, 2, and 3, we'll get the piece between 1 and 2. Now let's look back at the chart. The next set of 4 we want to grab overlaps the previous set by 3. So we'll grab 1, 2, 3, and 4. We'll join up points 2 and 3. And now looking back up at the curve, the segment between 2 and 3 will get drawn. Because point 1 is still involved in there, and point 4 is involved as well, we know it's going to smoothly join up with the curves on both sides. That's the reason we have those extra points, even though they don't get drawn. They help shape the curve and guarantee smoothness. The mathematics works out so that we will always be sure it's smooth. Well, we can just continue this process now. We'll just keep drawing new segments that overlap by 3 with previous ones, and as long as we obey that rule, we will always have smoothness. Notice where we are now. We're about to draw the curve from 5 to 6. If I grab the 4 vertices, look in the chart. Look at which 4 vertices I grab. 4, 5, 6, and 0. That's why I said in an earlier video, if we want to draw a closed curve, we repeat the first 3 vertices. It's because that now gives processing enough information to draw the remaining 3 pieces of the curve. So now we're going to join 5 and 6. So I'll put a little bar between those 2 in the chart, and I'll draw the curve between 5 and 6 on the whale. Now returning to the chart, we're going to draw the next 4. Those are vertices 5, 6, 0, and 1. The segment we draw is between 6 and 0. Looking back up at the curve, we can draw that little bit. Now we have one more to draw to get all the way around. Looking back at the chart, that's going to be the next set of 4, which are 6, 0, 1, and 2. The two vertices that this connects up are the middle two, 0 and 1. Looking back up at the curve, we join up 0 and 1. And now we have a closed, smooth curve. Processing is doing this for us automatically when we use begin shape and end shape. But now you know how to do it yourself. Just make a bunch of calls to curve, each one of which takes 4 vertices, x, y, x, y, x, y, x, y, and it draws the little bit of the curve between the middle two. As long as your segments overlap the way they do in this drawing, everything will be smooth. So to remind you, this is the heart of the Catmull-Rom curve. We have 4 points. We draw the little segment that's between the middle two. To draw that segment, we call a curve with 8 numbers, the x and y of the 4 points that are involved. Now you know the heart of Catmull-Rom curves.